Welcome to this webinar, an introduction to GraphQL and what it means for Drupal. Super excited to have members from the engineering side joining us on a busy build week. I will hand it over to Preston in a minute.
Alrighty, hello everybody and welcome. I want to have a special welcome especially for Sebastian Simpson, who's joining us across the pond. Welcome Sebastian, how are you?
I'm good, thanks. Thanks for having me.
Alrighty, great. So we just want to welcome all of you. We both want to welcome all of you to Introduction to GraphQL, what it means for Drupal. My name is Preston So. I am, well, first let's introduce Sebastian. Sebastian, you want to say a few words about yourself?
Well, I'm a software developer based in Austria. I'm originally from Germany, northern coast of Germany. And I've been living in Austria for the past 7 years, working for Sensations for the past years, and well, quitting my job recently, and now moving on to new adventures.
So northern Germany, is that like the Kiel area up there?
Yes, pretty much.
Okay, cool. Alrighty, well, welcome Sebastian, and I'm Preston. I have been working in Drupal since 2007. I'm development manager of Acquia Labs here at Acquia. And you can find both of our contact details on the slides here. So what we'll cover today is some information in general about GraphQL, what GraphQL is exactly, and how it changes the ways that people might be building typical RESTful architectures. Typically today you're using RESTful APIs to power your application architectures, and we'll talk a little bit about how GraphQL sort of upends that paradigm. We'll also delve into GraphQL syntax in terms of how you can actually use it against Drupal 8 when the module is released, and we'll have Sebastian to talk about that at length. We'll also talk briefly about the type system and the schema system introspection within GraphQL, which is one of the most powerful features and compelling features within GraphQL. And finally, we'll have a bit more of a broad discussion between Sebastian and myself, as well as Q&A about the future of Drupal in light of GraphQL. And so let's go ahead and move forward. So first we'll talk about GraphQL and REST. So what exactly is GraphQL? Well, GraphQL, simply put, is a declarative query language, which is also an application level protocol. What this means is that it's a form of communication between different applications, whether on the server side versus the client side, except that it is really agnostic to what the application actually is. And what this means is that regardless of your protocol that you're using, whether it's HTTP or SOAP, GraphQL is meant to abstract away those differences and work across the boundary of server and client. So a couple of notes about GraphQL. There are similar approaches to GraphQL. One interesting example is Sparkle, which describes function calls rather than actual queries to a database. So we're not actually firing GET requests with this. We are actually providing abstraction above that with GraphQL. And what happens is on your backend, you will have a GraphQL server which takes in these requests and interprets these calls. And then queries the database as basically as that form of middleware between the database and the data fetching mechanism. And as I mentioned, GraphQL is entirely agnostic to the storage layer and can be used as a proxy or relay system to forward API calls. So briefly, I just want to delve just a little bit into the history of GraphQL. As many of you may know, GraphQL was invented by Facebook, and it was really sort of promulgated during the conversion of Facebook's HTML5-based mobile applications into more native mobile applications. And so one thing that I do like to say is that if you have been using the Facebook application on your iPhone or your Android device, chances are that if you've been using it in the last couple of years, you've been firing GraphQL queries from those devices. There's also now a framework called Relay, which you can use in conjunction with GraphQL for your React-based applications. So what are some core ideas of GraphQL? Well, I think the most important thing to keep in mind with GraphQL is that you have a co-location. Just as React is very famous for the co-location of HTML and JavaScript, in terms of GraphQL, you're co-locating the data fetching specification, what the client wants to fetch in terms of data, alongside the sort of markup where it's located, right? So in this case, it could be a React component, or it could be JavaScript that you're using on the front end. And we're not going to embed this logic in a custom endpoint on the server. And we'll both delve just a little bit into some of the problems with doing that in just a little bit. So the core sort of main idea of GraphQL is that the client requests and client requests and server payloads adhere to a shared shape. What this means is that the shape of the request and the shape of the response are mirror images of each other. Basically, they are the same. They look the same, and the JSON that is produced is maps on pretty much, in terms of structurally speaking, quite accurate, fits the actual GraphQL request like a glove. So what happens is the GraphQL server is what houses the schema, and the client dictates what it wants the server to provide for it. This is a very new idea and a very important idea in terms of client-side applications, because now you have client-dictated queries. The agency for what the response is going to be is held with the client, not with the server. So what are some limitations of typical RESTful APIs? Well, there are 5 really major points which are problematic in terms of the typical approach that you'll find these days with REST APIs. The first is you have many endpoints. Oftentimes you'll have endpoints that are specific to individual views or that are ill-suited for trees of related resources if you have a very complex or very relational view that you need to build. This can lead to very bespoke or ad hoc endpoints or multiple endpoints that you need to fetch from, which is not ideal and also not RESTful. You also get a high degree of response bloat. Oftentimes, because you've written the REST API for a single use case in mind for a single client-side application, clients that only need a limited amount of data will probably need to contend with these ever-growing payloads that are really destined for other clients. So let's say that you have an iPhone application that needs different data from your Apple Watch. Well, that's going to lead to a whole lot of problems in terms of differentiated data. You want to be able to limit the data that you're sending to your Apple Watch. And so in this case, what's happening is these payloads will increase in size even though the data that you need from that payload stays the same. If what is fetched for your view is complex or relational, multiple client-server round trips and corresponding bootstraps will need to happen, this will delay the render process. Essentially, this is very problematic for Drupal, which has a reputation for being a very large bootstrap, and oftentimes this will really, really heavily delay the render process, which is not desirable for performance.
What's also important to note, we spoke about having multiple different endpoints and having bespoke and ad hoc endpoints. There's also a maintainability burden. Every time you add a new custom resource to your stack, you have to maintain it on both sides of your application, both on the front end and on the back end. And also, if you are dealing with a JavaScript application, you have to solve the asynchronous problem. And as soon as you add additional layers to that, it gets really, really hard. And solving all of your data requirements in a single request really makes it much, much easier.
That's a very good point. Absolutely. And also one of the big sort of limitations of REST APIs as they are built today is the lack of backwards compatibility, which means that REST APIs today tend to be versioned by nature, and so they become more obsolete as clients' needs evolve. And oftentimes, when you switch over your API version to V1 or V2, to V2 or V3, you're basically having to update your client-side applications as well and rewrite all of those queries. Also, one of the big problems with REST APIs is that they're not introspective, which means that you have no ability to actually see what the schema is and also what the type system is underneath. making client-side tooling and validation difficult. How many people, I'm sure many people on this webinar have faced the problem of not being able to see what exactly the REST API will give you in terms of its underlying schema. And this is a very important problem when you're dealing with especially client-side validation of these queries. So how does GraphQL resolve some of these limitations that we've highlighted? Well, the first is that GraphQL has a single shared endpoint. That's sort of the idea of GraphQL. Your GraphQL server lies at a single shared endpoint, and this GraphQL server will resolve these queries into root calls and send back a single unified response. So you get one single endpoint and one single response. Also, tailored responses, as I mentioned earlier, client-driven queries. That means that the response is catered to the demands of the client rather than the limitations of the API. And so oftentimes you'll get, you'll contend with the brittleness of APIs where your backend developer who's made this API will say, hey, I really don't want to have, now you have a blocker where you have to ask the API designer to actually provide this new data. And by having client-driven queries, you define a schema that is underlying and is universal, and any query that you fire from the client side will get the response that it needs. Also, there are fewer round trips, and this is very important from the context of the Drupal bootstrap. A GraphQL server will return a single response to match the request structure from the client. And this is flexible enough to accommodate a whole bunch of possible relationships. So if you have very strongly relational data that you need to fetch, a GraphQL server will handle that intelligently for you in conjunction with the backend that you're using. Also, backwards compatibility. Because the client is driving the query and driving the decision of what data it needs to fetch, you can actually have your client provide the same query to multiple versions of your API, even if, and actually you might not even need versioning in this case. And you can expect a common response no matter what, because of the fact that you're defining the query from, you're defining the fields in your query from the client side.
This is actually also built into the schema. There's a type where you can specify that a certain field of your object is now deprecated, and it will then not appear in introspection anymore, but will still work. So if you call it directly, then it will still give you a response, but it will not appear in introspection.
And so that's one case where, basically the GraphQL server will intelligently provide you that feedback of, there will not be this field, right, because of the fact that it's been deprecated. So even if you send that query with that field contained, it will skip that field. So the last thing,
it will actually work with that field. It will still give you the response that it used to give you, but it's not contained in the introspection, the schema introspection anymore. The new users are not going to see it anymore.
Yes, the new users of the API will not see it anymore. Correct, yeah. Mm-hmm. So just to jump off of that introspective point, we were just talking about the schema. GraphQL has a native and highly extensible schema and type system that you can extend yourself, and we'll talk briefly about that as well. So one important point to keep in mind is that GraphQL is not REST, but it can be. Typically, your API is usually a spectrum of different interpretations of REST. For example, if you're using the services module, the services module is explicitly not RESTful, which means that if you're adhering to Roy Fielding's original specification for REST, you should be using core REST and not services. So based on the spectrum of different interpretations of what REST is, GraphQL sort of goes above all of that. You can use GraphQL with a REST layer if you want to, but it's not a hard requirement. As I mentioned earlier, you can use GraphQL with SOAP, DDP, other protocols which are more relevant to IoT applications or appliances and things of that nature. As we say, where's the guy who's using REST correctly? There are actually not that many people who are actually using REST in the way that REST was originally defined. GraphQL sort of resolves the fact that many people who build REST APIs may not actually be making them as RESTful as they think, so to speak. So what are some criticisms of GraphQL? Well, it's important to keep this very balanced. Some criticisms include that you can actually have additional REST endpoints to provide smaller subsets of data. That's certainly a possibility. But again, in terms of endpoint design and ensuring that your API is lightweight, it will result in a whole lot of other endpoints that you need to consider, which can complicate architecture. Also, there is the very important point of HTTP, which can handle multiple parallel network requests. And thus can resolve this issue of having to make multiple round trips. Also, there's a concept in HTTP called content negotiation, which allows you to request multiple versions of a document or have differentiated versioning of a document at a single route. And this resolves the issue of API versioning, but at the same time, it's problematic because it really relies on HTTP, and not very many people are aware of this approach, that might be something to contend with as well. And HTTP also has a built-in type system, believe it or not, which is analogous to, but not very similar to, GraphQL's native type system, which is more based on the Go type system, and also can accompany standards such as JSON schema, if so desired.
Another criticism that I've heard quite a few times is that GraphQL doesn't respect the different request types, being like GET and PUT requests. And there's some things that follow that problem. So caching post requests is quite tricky on the client side. And if a GraphQL query gets very, very long, you can't send it as a GET request anymore. So you have to send it as a POST request. But there are ways to solve that problem. And we can talk about them later if you're interested in that.
Absolutely. Yeah, please feel free to put in some questions for us at the end. We've already got some questions coming in. We'll be talking at length, just sort of a larger discussion at the very end of this. So there's also a changing server. The relationship between server and client is changing. GraphQL really moves the server-client relationship to a new paradigm, in that the server publishes its possibilities, in that the server gives you the schema of what you can, of the full potential range of queries that you can send to it, and the client specifies its requirements. It's a sort of a revolutionary idea that turns our whole conception of what the relationship between server and client is on its head. All right, so with that in mind, I want to jump right into GraphQL syntax very briefly here. And I will give fair warning, some of these examples are possible within the upcoming release of GraphQL module in Drupal 8, and some of them are mere pseudocode examples that are not functional. So I will try to be very clear about which ones are correct and which ones are not valid, based on the Drupal 8's implementation, based on Sebastian's implementation of GraphQL in Drupal 8. So the first thing that we'll talk about is operations. As you can see, the structure of an operation is very similar to a typical JSON object. You can see the curly braces right there. A query, in this case, is a read-only fetch. And GraphQL models two types of operations. We'll talk about mutations shortly, this is a query right here. But one thing to keep in mind is that queries can be named, and these names are case sensitive, and they can also be anonymous. Now, just to delve right into what you would normally do with the REST API in Drupal, what you might do with core REST is you would fire a GET request that triggers, that basically fires a GET request against the Drupal core REST API, and the response you get is a JSON payload which contains a whole lot of information. Now, one of the core problems of Drupal's core REST API and REST APIs in general is, what if you only want to fetch, let's say, the NID, or what if you only want to fetch the title of your node? And this is really not possible because you're getting a very heavyweight JSON payload in response to your request, which is not really ideal for especially applications that really would prefer to deal with lightweight payloads of data.
Also note that this basically contains the entire schema of the node, or the entity object in this case. containing irrelevant information, like making the node ID an array and giving it a value property, although those are single value fields and they don't have multiple property values nested beneath them.
That's a very good point. Exactly. In order to traverse this from a client-side application perspective, you would have to basically write, provide an index of 0 and then dig down even further into the value property, which is not desirable for someone who just wants the NID and nothing else. What if you only want the title, as I said? Well, enter GraphQL. And we'll talk a little bit about fields here. So what you want to do, and this is a working query within GraphQL Drupal 8, fields describe relationships with other data. What happens is fields return values, and they can also carry arguments. So in this case, what we're doing is we're providing a selection set which consists of a single field named entity, and that contains that has a relationship with other data contained therein. For example, this node argument that you see provides an NID of 1, and what we're doing here is we're fetching the title and the created timestamp for node. And also remember that you can comma separate these or separate them by character terms. And what this will give you is a JSON response that's shaped exactly like this object that you see here, this query that you see here. And more than one argument is possible in an arbitrary order. So, for example, this is not a working query in this case, but if you were to want to have an image default field, for example, that's present in your node, and have arguments that dictate which image style, for example, gets sent out, you can provide arguments that will actually give you that correct image style. Another important point is that fields can be aliased. So let's say you don't like to have entity in your JSON payload that's part of the response. In fact, what you actually want is to rename that to content. It could be because you have some further logic on your client side that's dealing with some other names, and you need to rename your overall object to rename certain properties in order to get that to work properly with your application. There's various applications for that, including the idea of disambiguation, where if you have multiple fields being used and you need to disambiguate between them based on their arguments, aliasing is a very good use case for that. And once again, I will note that this is not currently, this is a fictional query.
Just to add, this query actually works, the one with content and then just fetching the title and the created date. But aliasing in this case is very useful for fetching multiple nodes with different IDs in a single query. So you'd alias them by node 1, node 2, node 3, etc.
And what that will give you is an array of each of those nodes, right? So you'll have node of ID 1 with title and created, and then another object that contains title and created of node ID 2, right?
Yes, exactly.
Yeah. Alrighty. Now let's delve into fragments, which are one of the more compelling features of GraphQL, which is that fragments will allow you to reuse fields. And basically what we're doing here is this ellipsis defines a fragment, this ellipsis invokes a fragment which we're defining elsewhere. And on the next slide, what you'll see is the definition of the fragment. In this case, what we're doing is, because we know that we want to generalize this query to be applicable to all nodes, we want to fragment out the notion of custom fields because every content type has their own custom fields. And so what we're doing in this case is where we have a separate fragment for custom fields on a specific type. And this type is entity node article, and it only deals with the article content type within Drupal. And so in this case, what you'll notice is we've got our custom fields, namely, for example, field author and field tags. And you'll notice that they're camel case rather than underscore separated here in order to adhere to the general casing that you find in GraphQL. And fields and fragments are added at the same level. So if I go back to this earlier example, both field author and field tags will be sibling to title.
What is important to note is that these fragment spreads are only going to work for entity node articles. So you could even have multiple different fragments on the same selection set, which pull in different fields based on the type of the node that you're currently looking at. So if you fetch a list of nodes and you want to fetch different fields for every type of node that is in that return set of data, then you can totally do that by specifying different custom field selector fragments.
Absolutely, and you can differentiate that based on type. Yeah, very, very compelling feature of GraphQL, which means that you only get the custom fields you need. Okay, so next is fragments can be arbitrarily nested. So what that means is that if you need to nest your fragments, you can actually do that very easily within GraphQL. So that's a very powerful feature as well.
This basically means that you can just send further in the object graph and follow entity reference fields into the referenced entities, for example.
Mm-hmm. So as Sebastian noted earlier, fragments declare types, which will facilitate these conditionally applied fields. This makes sense if you have your custom field for author only available on article, your custom field for tags only available on basic pages. This is a way to differentiate between those. Next is the concept of inline fragments. So if you don't want to use the fragment definition system where you're basically taking out fragments from where they're invoked, you can actually define a fragment directly on the query itself, namely by using the ellipsis and the on keyword, and you get everything you need there. So it can improve code legibility, and also you can have anonymous fragments. As you notice here, in this case, the fragment is not named. So variables and directives. Well, this is a very, very important topic in GraphQL, which dives a little bit more into things like caching. So a client-side application, for example, can use a build task to extract GraphQL queries that contain variable placeholders from a configuration file that are actually tied to server-generated endpoints. So, for example, if you want to, for the purposes of caching, you only need to send over variables over the wire. You don't need to send over the entire query because you want to limit it to just one get. And you also want to limit the amount of material that you're sending over. So variables are defined at the top of, and they're also scoped to individual operations. So what you'll notice here is that what we're doing is we're defining the type of the variable that will be accepted, which is an integer here in this case, and NID is used later on in the query operation to actually get the individual node that you're fetching.
This is basically one of the ways to solve the problem of using GET requests exclusively for with your GraphQL implementation on the server. So what you could do in this case is set up a full-blown GraphQL server, but obfuscate it by exporting just a set of queries and only making them accessible through normal routing, which internally then call the GraphQL query, but also by allowing you to pass variables specified in that query to that dedicated resource, to that dedicated router entry. And by that, you can basically obfuscate that the server is dealing with GraphQL at all. You can only make certain parts of the GraphQL schema available, and you can use GET because the query size is never changing. It's always only the route plus the variables. So that works for very, very large queries.
Another very important topic in GraphQL is the idea of directives, which alter execution behavior directly. Which means that if you want to conditionally include or skip fields based on your based on the variables that you've been provided, you can do that as well. This example, this slide looks like it got a little messed up, but in this case, what would happen is, for example, if you're providing a Boolean as your argument and that variable is used later on, you can include a conditional statement, namely if colon. So, for example, we can say if colon the Boolean is true, then in that case you will actually include a certain field or exclude it in that case. So there's also the very important idea of mutations. And in mutations are write operations. Basically, they are a write operation followed by a fetch of that updated data. Currently, they're not available in the initial release of GraphQL, so both of the examples you see here in terms of mutations are currently pseudocode or will soon be reflected in the implementation. But in this case, we have an update title named operation with a set title operation that, set title field, which is interpreted with an argument, new title, and then that gives you the actual mutation itself. And then the actual fetch is contained therein. You will get the title back of that node. So here's an example, for example, of a case where you would replace this with replace the post request with this sort of an approach. You can update a node by providing the ID of the node that you're targeting, and then any values that you want to update that with. So now we're going to talk about types and schemas. So the important thing to keep in mind about types and schemas is that in GraphQL, schemas define the capabilities of your GraphQL server, namely which types and directives it supports, and it's also responsible for making sure that you have validation for your queries. So next is the idea of, so any type system in GraphQL should have these general types here. So types are objects that are validated against and represent the full breadth of selectable fields. So namely, you see here a type of entity node article. And I'm going to actually move quickly through the type and schema system. It's very interesting, but we do want to get to some more discussion, so I will move forward quite quickly through this section here. So in this case, what we're doing is we're defining a type object, which is entity node article, which you might have seen before from the fragments in the previous slides that we dealt with. And what we're defining here is we're basically defining what inputs this type object can take in, namely two strings, which are title and body. You can also have types refer to other types you created or recursively to itself. And so in this case, this example is a little bit incorrect, but what you should see under that related value is entity node article, meaning that there's recursion here. And what that means in this case is if you have related : entity node article, what you have is that if a type object is nested within another, you have to select the field that's contained therein. Otherwise, it's not valid. So for example, this is valid, but this query is not, because you're not selecting the field within related as well. You can have object field arguments where you define which arguments can be that a field can take in, and also define the type that is used there. So interfaces are implemented by GraphQL objects in case a field is present on sibling types. And Sebastian, how do interfaces currently work with the underlying entity node object in GraphQL?
Right. So what we have right now is we have interfaces on the entity type level. So every entity type, every content entity type at this point is an interface, and the interface contains all of the base properties of that given entity type. And then each bundle in that is contained within that entity type is an object which implements that said entity type and provides custom fields that are only configured for that specific bundle in that definition.
Awesome. So as you can see, this is the syntax that is reflected by what Sebastian just talked about with interfaces. So in this case, what we're doing is we have that underlying entity node interface and type objects that implement that interface here. And as you can see, that's what gives us our fragment and the ability to differentiate fields based on type. So introspection, one of the last things I want to mention, and I'll just very quickly blow through this, is that you can use the built-in __ type field in order to actually dig into your schema. So what this will yield is a JSON output which contains the name of all of your fields, and then within those fields, it will give you, the first name that you see there is going to give you the name of the type, so entity node article, and the fields therein, all the names of the fields, and then all the types of the fields and their names as well. And then you can also use __ schema to access those default types as well. And both of these will work in terms of introspecting GraphQL. Okay, so now let's talk about GraphQL and Drupal, because that's the reason why so many of you are here. I want to go ahead and switch my screen very briefly here to allow Sebastian to show off just a little bit about how GraphQL works in relation to Drupal 8.
Right.
So 1 second here, let me just get this going.
Okay, so this is a normal Drupal 8 installation with the Drupal 8 GraphQL module installed. What you're looking at right now is the graphical interface. It is another open source contribution by Facebook, which uses the type introspection of the GraphQL server to render a visual GUI, which basically an in-browser IDE in which you can craft GraphQL queries based on the exposed types from the GraphQL server schema.
Hey, Sebastian, do you mind zooming in just a little bit? Do you mind zooming in just a little bit so we can get... There we go. Perfect. Thank you.
No problem. The schema that we have here right now is slightly different from the version that is currently exposed on the Drupal org project page. This is a couple of days ahead, probably like 2 weeks ahead of what the Drupal org project currently holds. And what we are currently exposing are content entity types, and we are exposing them both through direct ID queries as well as entity queries, which work without having to configure any views, although view support is also built in, and I'm going to talk about that briefly in a couple of minutes. So first of all, you can, as we talked about earlier, specify a query with the short syntax, just giving the curly braces. And then we can specify that we want to fetch node ID 5, and then we can specify that we only want a title. And this is going to be the response for that. And you can also decide, based on the auto-completion, what other fields you want to have. So by hitting Control Space, you get a selection of fields that are available. And these are all fields of the node entity interface. And we don't see any object fields that are related to a specific bundle, but we can do that by implementing one of the fragment types, and you also get auto-completion for these. So if you want to fetch a specific field, for example, tags for entity node 5, and then fetch the name of those tags, you could do this. Right, and this is the response. This is available in here because we have specified that we want to look at the article fields. What you can also do is you can descend further in the object graph. I actually also did this here because this is loading entities, tag entities, and then fetching properties from those. You can also look at other properties that are nested inside of each of the tags. But if you wanted to load the author of that node and fetch, for example, the username, you would do it like this. And the email address. What you this is actually my private. Don't use that. What you could also do is you could now, after fetching a user ID, you can also traverse into the reverse relationship, meaning that you can now fetch all of the nodes that currently have this user here marked as the author. So we can basically say, give me all of the nodes that this user has currently referenced as author, and fetch the title for those. So these are the nodes that the user, the author of the first node of ID 5 has created also. And as you can see, the second article is also part of that data set because it was also created by that user, obviously. We also have view support. Or actually, let's look at entity query support first. So the same entity types are exposed via entity query. And this gives me access as field arguments, which are going to be used as query arguments of any of the properties of the node type. So if I want to fetch all of the nodes that have this title here, and then also again show the username of the author of the node, I would do it like this. Or if I wanted to use a list, I wanted to load a list of nodes in a single query, I could also do this. And then I want to load node 4 and 5. And to validate that that is actually correct, I want to output the node ID. And also relations, as you can see here, work in lists as well. We can also look at views. So views support is enabled by a custom GraphQL display plugin. And what that essentially does is it loads the entities and passes them on to GraphQL as the context. So it doesn't have any fields as for configuration. Instead, it exposes the entire node entity schema as well. And you can have filter criteria here. It will also work to use these filter criteria here. If you expose the filters, it will also work to use them as field arguments in your GraphQL browser. But the way it will look, basic view support is this. So the demo view and the demo display from that view. And then in here we have access to all of the node properties again. We can fetch all of the titles of all of the nodes that are currently published. So if I go ahead and unpublish one of the nodes, how's it going to work? I've never used that before. How do you unpublish? Save and unpublish.
Yeah, right there, yep.
Right.
Drupal 8.
And then we only have 2 left. Yes, exactly. Then we only have 2 left here. Another feature that I'm going to add in the near future is contextual filters in views, so that you can use views as fields on your node or other entity types. So if you configure a contextual filter of type node ID, the view will appear under the schema of that node type and allow you to query a list of other entity types based on the context in which you're currently in. Right. I think that's it. Keep in mind that the demo here is currently looking quite different from what the Drupal module right now holds on the project page. We are very close to publishing it and pushing out the first release candidate. The release candidate, or the idea behind the module, is to generate the schema as a whole, and only as a second version of the module, we will enable GUI-based configuration and aliasing of fields, so that you get more control of what the schema actually exposes and how it exposes it. The first step would be to finish and polish the implementation of the GraphQL schema based on the type data information. And then once we have a first release out, we'll work on the GUI for making configuration possible.
Yeah, and I'm sure there'll be a lot of people who are excited to contribute to that GUI experience.
Oh, I hope.
Because, oh, absolutely. Alrighty, well, thank you so much, Sebastian, for that demo.
No problem.
All right, and now let's go back to the presentation here, if I can. Okay. Oops. There we go. Okay, so that was GraphQL in action on Drupal 8. Just to move on, some next steps for the module. So Sebastian, tell me, so I know that you're going to add support for mutations. What's that going to look like?
Well, so mutations, there's a couple of very interesting ideas about mutations that we can look at. First of all, obviously, we will have basic entity property and field update functionality as mutations. We'll have the ability to add items to field lists where the field cardinality is larger than 1. You'll have the ability to delete items from a field list, and we will have the ability to integrate with other modules. So for example, I'm looking at integrating the rules module so that you can execute arbitrary rules that mutate data of some sort, and then based on the returning data structures of that rule, you can then query fields of those mutated data sets that will spit out by Drupal afterwards, by rules afterwards. I'm also going to look into views bulk operations, so having a view and then doing multiple operations on a whole set of entries. But that's something that is going to be worked on as part of a second version. So first of all, we'll finish the fetching part, then finish the GUI for configuration of the fetching part because it's the most critical thing right now, and then mutations will be the second part of that implementation. But I'm very happy to welcome contributors who want to work on that.
Great. Well, count me on that list, Sebastian, for sure.
Awesome.
All right, so we want to get to questions very quickly here, but I do want to mention very quickly that GraphQL, first, Facebook has some support for WebSockets in terms of GraphQL. Do you want to say a few words about that, Sebastian?
Right. So WebSockets is a very interesting problem because we're dealing with PHP here. PHP currently doesn't support that. There might be PHP might support WebSockets in the future, but right now it's not on the horizon for us. So I'm thinking about a way of supporting that by adding like a middleware based on Node.js, which deals with the subscriptions and then notifies Drupal of the currently running WebSocket connections that are subscribed to a certain query. And then again, Drupal will update or send a notification to the Node.js server whenever one of those data structures is touched by another user or yourself even, and then the Node.js server sends the update notification to the client. So that would be a working version based on Node.js. And we have seen WebSocket implementations with that kind of middleware in Drupal 7 already, not based on GraphQL, but on other modules, and it works. So that's the pathway that I'm trying to look at.
Yep, absolutely. And of course, one of the big problems with WebSockets and PHP with Ratchet, I see a question coming in right there, is that you cannot use a traditional LAMP stack with Ratchet. Ratchet needs to be a standalone service outside of Apache. Apache is not designed for publish-subscribe. Which means that handling multiple connections that are persistent is very challenging. And so it really complicates the infrastructural question of Drupal. Okay, so I want to just dive right into the questions at this point because we only have a few minutes. But I do want to mention 3 very important considerations for decoupled Drupal. I know Sebastian's dealing with integrating with other modules, such as getting rules triggers to do certain things with GraphQL. If you're interested in that, we can talk further about that later. Also, client-side applications like using the Redux library in conjunction with React. Those are very popular for approaches with GraphQL. And then finally, request caching is a very, very important topic. And I encourage you to get in touch with both of us to ask questions about request caching and so on and so forth. So with that, here are just a few questions that are up for discussion that I want people in this webinar to think briefly about. With that, let's just move straight to the questions here. Okay, so the first question comes from Amidan, I believe. The first question is, any thoughts on mocking the Drupal GraphQL data store so that front-end devs don't need to configure Drupal locally on their dev environments? Sebastian, any thoughts on that?
I think I don't understand the question. So you want to mock Drupal, the Drupal data structure locally for a front-end developer so they don't have to set up Drupal. Is that correct?
Yeah, I believe that's what it's asking, yeah.
Okay. I think it would work because you have all of that information available, and that's where the introspection part becomes very interesting because you have all that information about your data structure, and also you know at what point you have reached a nesting level at which you only return primitives like integers or strings for your entity properties. So you could definitely mock it, and it's made possible by and it could be made possible by the GraphQL JS implementation, which also powers the graphical UI. Yes, it's definitely possible, and it would not even have to be tied to Drupal. It could be a generic solution which simply outputs data, for example, using the one of the Node.js modules. I think it's called Faker, right? Which simply outputs strings. That would work, definitely.
Sure. All right, so just in the interest of time, I'm going to jump ahead to some of the other questions as well, just to make sure we cover as much ground as possible. Any thoughts on previewing non-final workflow content states through GraphQL API and native JavaScript applications? This is a very important question. I believe what this question is asking is about things like embargoed content, different content states in relation to, you know, if something is still in moderated mode and is not meant to be published on the site. How do you envision grappling with that in your implementation, Sebastian?
Right. So first of all, we are using entity and field level access checks provided by the entity and field API. So if your entity is not accessible to you because of some sort of condition, either not being published or having some other moderation state that doesn't allow you to see it, then you won't see it in the GraphQL response either. I've currently no plans to add any further access checking because the entity and field API access checks should be where you should start anyways. But you can definitely alter and provide custom schema entries so that you could override the implementation which is generated currently for a specific field of an entity, for example, and give it different access checks. But yeah, you should probably start by simply implementing custom entity access check rules first.
Very interesting. I think that's a very important question. So next is a question about sort of large queries, and I'll sort of combine these two questions into one. Say I'm building an application that uses GraphQL to get all the content or a large amount of content, or potentially I have a denial of service attack. Which fetches, let's say, 5,000 nodes. So I know that we talked very briefly about request caching, but is that one of the ways that you can prevent things like denial of service attacks or very expensive queries?
Yeah. So denial of service attacks can happen either way, and there's definitely room for somehow preventing large requests from hitting the GraphQL schema, but generally, you want to prevent them from hitting your server initially. So you would like to, because you also don't want it to run the Drupal bootstrap, right? So you'd want to kind of, on the server infrastructure level, prevent that from happening. But you can also implement rate limiting, but that's out of scope for the GraphQL module. The GraphQL module only also as access checking is out of scope for the GraphQL module. That's something that you need to implement as part of your entity schema, and it's part authentication as well. So these are all questions that would be solved with other modules, I guess. And based on those modules, you can definitely implement rules for example, rate limiting your API. Large requests where you want to, for example, fetch 100 nodes and then descend like crazily deep into the object graph can get very heavy. So you would want to prevent that definitely as part of the schema. I have yet to figure out how to make the paging configurable so that you can ensure that a maximum limit of 10 entries, for example, for a given list is possible. And that's the hard limit right now. So I have currently hard-coded that to limit the response of lists to 10. But that's something that I want to make configurable for every edge in your object graph.
Great. So I think we only have time for one more question, which I think is a very interesting one, which is from Andre. Is there any way to programmatically change the model and schema? Obviously, things like computed properties are all the rage in the JavaScript world right now. For example, computed fields. Can you add computed fields to the schema?
This, I can answer it by saying yes or saying, well, it's already in there. So computed fields, anything that you have exposed as type data information is automatically generated as a schema entry. So even computed fields work because GraphQL doesn't operate on the database layer. It operates on the application layer and simply executes functions. We can also, through type data, fetch fetch computed property values. And you can still extend it though. You can add custom entry points, custom root codes to your schema, which, for example, if you wanted to fetch a list of all currently enabled languages in your site, which are not entities, you could obviously do it by simply providing a custom a custom language querying root call. And it's possible because it is all, everything that you see generated in the Drupal module currently is implemented as tagged services. So you simply need to provide your own tagged service, which exposes its own type of schema. And you can or cannot use the type resolver that is already traversing the type data information, if it's type data. It's up to you.
Cool. All right. Well, unfortunately, that's all the time we have right now. But thank you so much for joining us, Sebastian. This was a real pleasure. Please feel free to get in touch with both of us. We've got our Twitter handles up on the screen, our Drupal.org profiles, as well as our emails. So we highly encourage you to get in touch with both of us with questions about GraphQL in general or about GraphQL and Drupal. And please come to upcoming webinars as well that Acquia is hosting to get more insider knowledge and very exciting knowledge about the cutting edge of Drupal and web development. Thank you.
Maybe as a closing note, I would like to thank Acquia and Sensations for supporting me in working on the GraphQL module. Very nice of you guys. Thanks.
Awesome. Thank you.